Well, welcome everybody. Sorry for the sound issues for those who joined earlier, but we seem to have managed to solve everything. So yeah, welcome. It's St. Bridget's Day in Ireland, so the start of spring. We're looking at brighter days ahead, both literally and metaphorically speaking. And it's great to have Ekaterina Vylomova with us today. She is a postdoctoral researcher and I believe also a lecturer at the University of Melbourne. And her research is focused on morphology, on linguistic typology and diachronic language models. And she also works on neural machine translation. And she is closely associated with the two ACL working groups or special interest groups, namely a SIGType, which deals with typology, and SIGMORPHON, special interest group on morphology and phonology. And with the latter, she assisted in the shared tasks on morphological reinflection in 2017, 18, and 19. And today she will be talking about the Unimorph scheme, which is a universal annotation scheme and a multilingual annotation scheme for morphology. And I suppose more specifically, she will be talking about documenting and modeling inflectional paradigms in under-resourced languages. So it's great to have you here, and the floor is all yours.
Okay, thank you so much for introducing me. So today I will briefly describe how we created the Unimorph database and what challenges we faced during the annotation of languages in this universal morphosyntax annotation schema, and how we use the series of shared tasks to improve the annotation and evaluate the quality of that annotation. Okay, so, but first of all, by the way, if you have any questions, please ask them. So make sure that we do not lose anyone during this talk. Okay, and I will try to check after each subsection whether there are any questions in the chat. Okay, so I would like to start with a short discussion on NLP, on the current status of NLP, whether it is actually universal or it's universal. So the ultimate goal of NLP technology is to bring it to as many languages as possible. And here I put the Babel fish from the Hitchhiker's Guide to the Galaxy that was able to translate from any language to any other language. But the question is whether NLP is in that state. So as most of us know that there are approximately 7,000 languages in the world, approximately because there is a discussion what is a language and what is a dialect, right? So it's the boundary between two is very fuzzy and it's often a political question. And as Max Weinreich once said, a language is a dialect with its own army and navy. And when we look at languages in typology, we try to understand the variation in those languages. And here I would like to quote Roman Jakobson, who once said that languages differ essentially in what they must convey and not in what they may convey. And I would like to present some examples how different languages use different means to express the same things. For instance, if you think about the relations between words and what should be a subject, what should be object, and what should be a predicate. So in Chinese, you would express this in the word order. So Chinese is isolating language, which means it doesn't have much morphology, and it uses the word order to express the subject role, the predicate, and the object. So in this example, we have Roman, so which is we, so it's a subject, then we have the predicate, then a specific word that corresponds to the past tense, and then an object, these new words. So, and the plural is also expressed as a separate word. And this is different compared to Russian. So Russian has more flexible word order. And how does it express the relations between words? It uses morphology. So in order to say that something is an object, you would use the accusative case. So in this case, we have new words. They all have agreement in the case, and they all marked as accusative. And they all have the plural marker on them. And the subject is in the nominative case, and it has an agreement with the verb, so in the number. Okay, so this allows us to put these words in more free order. So we can put the object first, and then the subject, and then the predicate. And we will not lose much information from that. If we continue moving in this direction, so we will end up in polysynthetic languages. And here is an example from West Greenlandic from Michael Fortescue. So in such languages, we can have a single word that conveys the meaning of a whole sentence. In this case, we have a sentence, eat a dog, a reference to the dog, is good for catching polar bear with. So if you think of these languages in some extreme case, so you can recall, or if you ever read Robert Heinlein's novel, so there is a novel called Gulf, and in this novel there is a constructed language which is called speed talk. So in speed talk you have a very rich phoneme inventory, and the idea is that it's extremely efficient language in which you can express the meaning of a whole sentence within a short single word, so that you can communicate your thought extremely fast and efficiently. So, and another similar language, also polysynthetic, is from Australian Aboriginal languages. It's called Kunwinku. It was described in Nick Evans' papers. So, and here you would also have the same situation. So you have a verbal stem, and then on top of that, you have all these different morphemes expressing the relations between words. So this word over here conveys the meaning of I cook the wrong meat for them again. And here I would like to also mention the beautiful book by Ursula Le Guin. So that has beautiful this woman on the front cover that somewhat resembles a member of some Tuatha De Danann, probably. So this novel is called The Word for World is Forest. So it's about language and culture, how culture is reflected in language. In this specific language, they have lots of words about forests as nature, because this the people lived in those like world in harmony with the nature, and then it was colonized by some other, like actually those people from the earth. So and this novel was kind of inspiration for the movie Avatar that you probably heard of. So, and in general, so I try to outline some differences in languages, but a majority of NLP technologies only focus on most documented languages and most studied languages, such as English, French, German, Russian, Hindi, or Finnish. And of course, they are not representative of the whole variation of the whole linguistic variation. And one can say that most NLP is standard average European. So this term standard average European was coined by Sapir-Whorf in 1939. And recently, Martin Haspelmath listed some essential properties of those kind of European, or he called this universals. So those universals that only applicable to European languages. What do they have in common? For instance, they all would have definite and indefinite articles, such as English the or are, or a periphrastic perfect formed with have plus a passive particle, such as English I have said. Or typically in such languages, the verb is inflected for person and number of the subject, but the subject pronouns may not be dropped even when this would be unambiguous. And then this set, there are other features, and this set of features was also enriched with certain features that are common in European languages, but can also be found elsewhere. For instance, most European languages will lack a distinction between inclusive and exclusive first person plural pronouns. When you say we, including you, and we, or me, and we not without you. And they would also lack a distinction between alienable and inalienable possession. So inalienable means it's probably your body part, so you cannot just remove it. So, and if you look at WALS data, you can also see that European languages, they share lots of properties that you would not see in other languages. So for instance, if you train your system on this European or Eurasian languages, so it would most likely be biased towards learning suffixes rather than prefixes. Because you see that suffixing morphology is common in Eurasian region and in Australian languages. But if you look at Mesoamerican languages and African languages below the Sahara, they might either don't have any affixes or they have prefixes. Now, if you look at inclusive-exclusive distinction in independent pronouns, when you say we and including I or excluding I. So again, there is no such distinction in Eurasian languages. So it's all blue here. But you see the distinction between an inclusive and an exclusive in many Australian languages, and in African languages, and in especially South American languages. Again, if you look at possessive classification, whether there are any possessive morphemes, so and how many classes would you have? So you see that the whole Eurasia and Southeast Asia is filled with white points. So it means that they do not have any possessive classification. But it's very common in Australian languages, in some oceanic languages, and in African and American languages. And finally, the past tense. Whether you have the past tense that is marked, or you don't have it marked, or you have different types of remoteness, for instance, recent past or remote past. And again, here, Eurasian languages just have a single past tense, most of them. And if you look at Southeast Asia, there is no specific past tense marker on words. And if we look at African languages and some American languages, we see that they have different types of remoteness distinctions. So in general, you see that if you have a data set that mainly consists of European languages, so it means it's not really representative of the whole variation, right? And as I said, so typology wants to document this cross-linguistic variation. And when we create a unimorph, so we try to find features that are common across all languages. So why do we need unimorph? So unimorph describes the morphosyntax of languages. And in some way, you can probably think that Wiktionary has a lot of data, right? So when you think about some multilingual database, if it's just raw text, it might be Wikipedia. If it's some, for instance, morphology or etymology or translations, you can recall Wiktionary. And indeed, if you look at a list of languages that are covered, at least in English edition of Wiktionary, it states that there are over 8,000 language codes. So including some historic languages, like proto-languages. And you can see, if you click on each of these languages, for most of them, you will not have much data. So majority of them have very little data. But the major problem with Wiktionary, if you consider, for instance, morphology, so Wiktionary provides this inflectional table. So this is called the inflectional or paradigm table. It has several dimensions. So for this is an example for Russian word for male escapee, and the declension or by. So it's has two axes. One is grammatical case, and another one is the number. And in the intersection, you have the corresponding word form. So in nominative singular form is called lemma. It's our dictionary form, and there's other forms that are derived from that. So, and the major problem with Wiktionary, if you compare those different values of grammatical cases across languages, so the grammatical cases with similar functionality might have different names. It often highly depends on the descriptive tradition that was used in that language. For instance, in Russian, you might have this prepositional called as prepositional case. In some other grammars, you may have it as a locative case. And in other languages, you might call it essive case. And even within a single language, you might have variation how you call the grammatical cases, for instance, or even the number of those grammatical cases. In Russian, you typically in the standard textbooks, so you would find about 6 cases. But in some more specified linguistic literature, you might observe some extra cases, such as partitive or vocative, or some other extra cases, so up to 3-4 extra cases in Russian. So, and the goal of the Unimorph is to make a cross-lingual or universal annotation, so we can easily map these grammatical cases and their functions across languages. So in Unimorph, we identified 23 dimensions of meaning, such as tense, aspect, mood, or grammatical case, or grammatical number, and 212 features, such as past tense, present tense, and many others. So this was done in 2015 by John Seelig Glassman. So basically, this person was a postdoc of David Yarovsky, who spent 4 months in the library studying typological literature and trying to identify which of those dimensions of meaning are tested cross-linguistically and are sufficiently common cross-linguistically. And another feature of the Unimorph is that it's so-called amorphous morphology. So it means we do not try to segment words into morphemes. And the first paradigms for morphological inflection were extracted from the English edition of Wiktionary and then converted into this schema. So here is an example for Russian noun declension of the word abajur. So, and you see that all the data set in the Unimorph is described as a number of samples. So each of these rows is called the sample. And we have, the sample starts with the lemma, then we have the form and the slot that describes this particular form. For instance, the third row has says that it's noun, it's genitive case, and it's singular. And you see that it has some extra suffix "a" that corresponds to this specific slot. And the key feature and requirement of the unimorph is that for a single lemma and a single slot, we have a single form. So we cannot have multiple forms for the same slot for the same lemma. So it's not allowed in the unimorph. And this slot should accurately and precisely define the form. Otherwise, it will be ambiguous. So, and now the question, so I can stop for a while if there are any questions. So the key point here is to understand some of the terminology that I will use further. So the lemma, so we have a single lemma, abjure here, and a set of forms, and this set of morphosyntactic features. And this typically we have, for each language, we specify how many lemmas we have in the data set and how many samples. So samples means how many rows in this data set we have. So to make it very clear, because I will mention this in some issues in terms of representativity of the data sets. So if you have any question so far, you can raise your hand or I can move further. Okay, so I'll probably move further. So now the main question is how we move from language-specific features to the universal features. So to mention is the unimorph, the whole kind of approach of unimorph is to specify features that take some intermediate position between descriptive categories that are specific to languages and comparative concepts that can be used for typological studies. So this is all in the terminology of Martin Haspelmath. So again, he identified that there is some like descriptive categories that are very specific to languages, so you cannot actually use them to compare languages. And there are more general comparative concepts. When you transform categories into these concepts, you might lose some information about that language. And in the unimorph, we are trying to make the schema to make very precise description of the features and do not lose much information. So how we do that? So for instance, let's consider gender dimension. So typically in most languages, you would have either no gender marking, or you would have, if you have genders, you have either masculine or feminine or neutral, or maybe also distinctions between animate or inanimate as noun classes. And you would only have very few languages, language families where you don't have, that do not follow these distinctions. So one of the famous examples is Bantu languages. In Bantu languages, you have 23 noun classes, or in Dagestan languages, you might have from 2 to 8 classes. So here is an example what it looks like in Bantu languages. So in Proto-Bantu, you would have classes for humans and animals and other inanimate things. You would also have an extra class for kinship terms, for liquid masses. There's also another interesting class for abstract nouns, or for diminutives and different types of diminutives. So those are very specific to Bantu languages. So for them, we would use so-called LG-spec notation. So we would map each of these classes into LG-spec. So LG-spec stands for language specific, because this is something that is not observed in other language families. So we will not attempt to try to introduce new noun classes of that. So what about case systems? So in majority of languages, you would have some core cases, depending whether it is nominative accusative language or ergative absolutive. So you have either nominative accusative distinction or ergative absolutive. The non-tricky part starts with non-core cases. So John, when he studied typological literature, identified the following non-core, non-local cases, such as dative, benefactive, purposive, genitive, partitive, instrumental, and commutative. In languages like Russian, there is no such distinction between the two. Vocative and other cases. But of course, again, there are languages that have other case names or other cases. So what do we do with those cases? For instance, in event, there is a case called sublative. So the semantic something to be like something. You would human-like, animal-like. This into comparative. Or in many Uralic languages, you would have the case called abassive. So the semantics is specified without something. The derivation less. So this you would have a case. So you would have because of this, don't have a good match in the existing unimorph schema. And in this case, we typically run a discussion whether we need to introduce this new case into our features, or we just use LGSpec and we are fine with that. And in this case, we see that it's not this particular grammatical case is not that common. So we will just map this into LGSpec. And for instance, in Russian, you have a prepositional case. So it's case that is used with prepositions to indicate location or to say something like about a book. About a book, so the book will be in the prepositional case. So, and in our annotation, we just use ASIF for that. And of course, in many Uralic languages and other languages, you have lots of local specifying the particular place and how the distal subcategory, motion, and aspect. And in many Finnic languages or other Uralic languages, you might have extra cases such as inessive. So these cases can be expressed as a composition of existing unimorph cases. So inessive means to be in something. So we express it as the preposition in. So we have this in and essive. Or the case called elative, it means out of something or somewhere. So we express it as a composition of in and ablative. Or illative, it means into. So we compose it from in and elative. And the same for elative. And for instance, in essive itself is mapped into the formal case. What are the challenges with this case system? So we try to find this kind of nearest or the most similar case if we can find, but there are some other problems. For instance, in some languages, you have some features that correspond to combinations of cases with some other features or some other grammatical cases. For instance, in Evenki, you have the following feature, which is accusative, reflexive, genitive. So this could be mapped into accusative and possessive plus singular. So this PSSRS. So it corresponds to the possessive plus a singular number. or accusative definite is mapped into accusative plus def. So we have this particular feature, so we just compose them together. So this is to some extent resolved. Unresolved problem that is common in the resource languages that we initially did not have any way to address in the Unimorph is so-called case compounding and case stacking. So the Unimorph only allows a single grammatical case or a single feature to correspond to a single dimension. So if we have a dimension such as number, so every word form has a single number. Or if we have a grammatical case, we say that, okay, every word form has a single grammatical case. But there are languages where you have more than one. So here is an example from Besserman Udmurt, from Maria Usachova. So here is a sentence saying, he is giving the candies to the little boy with black hair. So this hair will be in instrumental case. So we have it as corresponding to with in English. It also have a possessive third singular marker. And on top of that, it will also have the dative. And the dative. So, and there is no way we address more than one case or are able to put more than one grammatical case in our schema and also specify the order. So we currently don't have such options. And it's even trickier if you think of languages such as Kayardilt. So Kayardilt is a so-called magical or unimaginable language, which is from Australia, that was documented by Nick Evans. And it can have up to 6 cases stacked on top of each other. So it basically, if you have lots of dependencies, so you have all the cases coming from all your dependencies. So in this example, with good graph with instrumental, but and on top also have instrumental good. And this is also common in Chukchi, in Shmerian, in Basque, and other languages. Let me check if there are any questions. If there are any questions, please raise your hand. So this is some of the issues that we face with under-resourced languages. And another important problem that you need to think carefully is which scripts and writing systems you use to represent language. So often, in many under-resourced languages and those kind of minority languages, you they don't have their own writing system. And for many of them, the writing was the USSR republics. And in the USSR, there was a program for the literacy of to bring literacy to everyone. And of course, for that, you need to have some written language. So, and many linguists worked on the development of scripts and writing systems for spoken languages. So, and if you look at these languages, you would see different writing systems. So, for instance, Bashkir has used Arabic before 1920s. In 1930s, there was Latin, and after 1940s, it switched to Cyrillic. And it's of this, for instance, USSR languages. So you see that in 1930s, they all attempted to use Latin, but then they switched to Cyrillic. some of them, such as Tatar, they tried to use Latin several times, and even in 2000s, there was an attempt to use Latin. Or if you look at Evenki, you see for Evenki, if you are in China, so they use Mongolian scripts, not Cyrillic, and it's typically a political question which of this writing system you would use. In many cases, you would probably try to use all existing scripts and data, but it's worth checking with native speakers which one they would prefer. Any questions? So I can stop here if you have any questions, because the next part will be about SIGMORPHON shared task and how we use it to improve the data quality.
Hi.
Yeah.
But I might have a question, but it might fit better in the next section. I was wondering, working on ancient languages or Old Irish in particular, I came across the thing in when you extract Wiktionary inflection tables that you kind of filter out, I suppose, some kind of, for example, with this infixation in Old Irish, infix pronouns, but they're kind of filtered out in the paradigms, you know, so there wouldn't be attested forms. They would be kind of normalized or by people who probably on Wiktionary input that data themselves. So they're not representative of what is attested. It's kind of hypothetical.
Yes.
They're hypothetical form. So how would you? But I suppose maybe this is better treated in the next section. I was wondering on the, you know, the data set and the data quality.
So basically in Wiktionary, you have, in majority of the languages that we worked with in Wiktionary, they are produced with Lua scripts. So if you look at the modules, so there are templates and modules, you would see that there are Lua scripts that provide the rules how to generate these specific tables. So often in such, especially like less studied languages, you might have these rules are derived from some transducers, for instance, and you might end up with many unattested forms. So in our case, of course, it's also a problem because often we don't have native speakers, and the linguists might also not know this language well enough to say that whether this form is attested or not. So we are trying to now use the textbooks and bring more linguists and native speakers so they can check the data. Because for some languages, we also have the data that is derived from some final state automata. And this means that you might end up with some potentially existing forms, but they were not attested at all. So we had, for instance, such in Uzbek data, where we invited native speakers to just check our data. They said like, okay, this potentially possible and it's grammatically correct form, but I've never seen it before.
Thank you.
Okay, so in terms of SIGMORPHON shared task, so we use this shared task for the three purposes. So first, we try to, of course, evaluate the systems in terms of how well they generalize across those different languages, the data, and so on. But starting 2020 or 2019, actually, we also use it to collect new data and to invite more linguists and native speakers to work on this data and to evaluate the quality of our data. So what this shared task is about. So far we have this unimorph, and we have these triplets of lemmas, tags, and forms, right? And the task is quite simple. So there are two tasks. One is inflection, where we provide the lemma and the target tags and ask the system to predict the form. and reinflection. So in reinflection, we replace the lemma with some other form of the same lexeme, and optionally with the text of that form. In this case, I just provided the form plus the target text. So it's running plus past tense. We expect to have ran. So, and typically when we started this shared task, we had the data from dictionary. It means we have full paradigms. But over the years, so we started collecting data from different other sources, for instance, from gloss text. And it's very rare that you would have full paradigms. So the task became more challenging for some languages. And typically, so if you look at the results of this task, so the winning systems now are all neural seg-to-seg models with some optimizations in terms of architecture, in terms of how the data is augmented with new samples, how you generate new samples out of this, what you already have. So I provided this technical details in my SIG type talk. And here I would like to focus on the languages themselves. So if you, as I mentioned, so if you look at our initial tasks, you would see that majority of these systems achieve over 90% of accuracy on high resource languages, but significantly less in under-resourced languages. So, and when we started, we tried to come up with some error taxonomy. So it's easier to analyze what types of errors do we have in such systems. So, and together with Kyle Gorman, we identified the following types of errors. So one is the free variation error. So when you actually have more than one acceptable form, so it's typically due to dialect variation, or it's often common in the oral speech. The other one is the error that is related to the dictionary itself. So it's extraction errors, when we incorrectly parse the table and our slots moved at some point. Or the dictionary error, or this initial linguistic source data error. So sometimes you might have errors in the initial data as well. Another type of errors that are produced by the systems, especially neural systems, is that some bizarre errors from the linguistic point of view, when instead of, for instance, mailed, you produce mumbled. Or if your system gets stuck in some infinite loop producing something like this. So it's very specific to neural systems. The most common type of errors, if you use high resource languages, is allomorphy errors. So it means you misapply some existing allomorphic pattern. And finally, if you have some standardized orthography, so of course there are some orthographic conventions, and your system might not capture this. So, and initially you see that we looked at some high resource languages, mainly in the European and Uralic, and you see that allomorphy is the most common type of error. So if you look at particular languages, you would see that it often you mispredict ablaut in Dutch and German, umlaut, plural suffixes in German, linking vowels in Hungarian, years in Polish, or genitive singular suffixes. Also, there are some kind of inherent morphology features such as animacy. In our initial data set for Polish and Russian, we did not specify animacy feature for nouns. So, and it's impossible, often quite challenging to guess from the word form itself, unless you observe, for instance, if you're predicting accusative case. In accusative for Slavic languages, you have different forms depending on the animacy. So if you observe singular form, you may predict the plural form, right? But if you do not observe any of these forms, so it's very hard to predict from the lemma itself, whether this is animate noun or inanimate. And the same for aspect in Russian. So we did not specify the aspect in our paradigm tables. And in Russian, you would also have some really weird compounds. And in many cases, you need to decide whether you inflect both words in the compounds, or you only inflect the second, or you only inflect the first. And currently, we also have another challenge is that you have very poor performance on unseen lemmata. So that's why we try to organize the VAC tests. And if you look at some under-resourced languages, there are some challenges there. For instance, some writing systems are more challenging. If you look at Tibetan, so in Tibetan, you have different components, such as top component, down component, base component, and different suffixes. So if you don't have enough data in your data set, so the systems produce impossible combinations of those component units. And we also looked at this language called NEN. It's Papua-New Guinean language with this interesting feature, which is called distributed exponents. So you can probably read a bit about it later. So, but what I wanted to say is that you can see how accuracy changes when we go from high resource language. So a high resource setting is that we have about 10,000 samples, so 10,000 vowels in our data file. So we have 65% accuracy. And if it's low resource, it means we only have 100 samples in our language data set. We get 8% of accuracy. And again, majority of errors are due to vowel harmony, and we also see that we have some impossible, extremely long words due to this looping effects. And for these languages, we also developed some tests in terms of how well they generalize. So I'll probably skip it for now because we probably a little bit out of time. So, and now let me just enumerate certain challenges that we faced with under-resourced languages. So this is the results of 2021 shared task. And you see that for some, so this, the upper part is Semitic languages, for which we have over 90% of accuracy. But there are some languages, for instance, Syriac, for which we have very low accuracy. Or this CKT corresponds to Chukchi, and Italman, or Kunvinku or Brush. So for them, we have also relatively low accuracy. And the same for Abela. So Abela has less than 10% accuracy, or at most about 13% accuracy. Or Evenki, about 50% accuracy. Or Shiba, it has about 30 up to 47% accuracy. So what is the problem with these languages? Is it the problem with the systems? Probably not, because we have different systems, but none of them achieved high enough accuracy. So it's about the data. And if you look at the number of samples and lemmas, we see that in Chukchi, we have extremely small data set. It's only 132 samples representing 118 lemmas. So it means we for each lemma, we have about 1-2 forms at most, and that's it. So for majority of the feature combinations, and Chukchi is a complex language in terms of morphology, it has polypersonal agreement and other features. So it's, of course, it's not enough to train and make generalizations. And the same for Kunvinku, or even for Evenki. So let me just provide some analysis of that. So for Evenki, the data set has been created from oral speech samples. And there was little attempt at any standardization in the oral speech transcription. So there is already a lot of variation in how you transcribe this data. And there is also extra variation coming from dialects. So, and one more complexity on top of that is that it has complex vowel harmony. So, and it's highly dialect dependent. So in Evenki, we have just a single data set that basically provides different dialects. And in terms of the schema, so we also have some inaccuracies. So when we try to map these features from event key into the unimorph, we mapped several different past tense forms into a single past tense. So it has this differentiation in the remoteness, but we map this into past tense. And the same for commutative suffixes, so that we're mapped into a single com feature. And there are some features that were not represented at all. So we basically had ambiguity in the description of the forms. Now, another language that it has very little data, as I mentioned, only about 100 samples, but we are trying to increase it to at least 2,000. So it's called Chukchi, or locally it's called Loara Vetlot, which is the language of real people. It's translated as such. So again, it comes from oral speech samples. It's a very small and sparse data set with polypersonal agreement and very productive incorporation. So it's a very cool feature of Chukchi that, for instance, if you would like to say, I'm reading a book, you would instead say, I'm book reading. Or in English, you have, of course, some cases like I'm dishwashing, but typically you would not say like that. In Chukchi, it's very common to have such constructions. And it has also complex vowel harmony. So when you train a multilingual system, so it will not actually be trained well and extrapolate to Chukchi, because it has very special, unique features. And this vowel harmony is one of those unique features. So you have morphemes that are called plus morphemes and minus morphemes. And if a word with minus morphemes gets an affix with plus morphemes, all the minus ones will turn into plus. So you have nut and nut, and it will be transformed into nog tak ti if you put this u at the end. So this u transforms into o, and a transforms into a. And another interesting feature that we were not aware of before we looked at Chukchi is that you have genderlects. So genderlects are kind of dialects, but for, so it's a kind of male language and female language. In Chukchi, for instance, if you want to say walrus and you're male, you would say rerke. And if you're female, you would say tse. So, and in male language, you would use R and RK. In female language, you would replace them with tse and tse. So, and in the current unimorph schema, we don't have anything to address genderlects and to differentiate this in if we have them in a single data set. Another interesting language that has poor performance is Italman. It again, it's because it's very small and sparse, and the verbs mark both subjects and objects. So there are plenty of different combinations like these ones. And again, because you have very small amount of data, you do not observe most of these combinations, and you cannot learn all these correspondences between the feature combinations and the particular tag combinations. Kunwinku. So Kunwinku is Australian language, and all Australian languages did not have their own writing system. So they are written with the Latin script. And of course, if you look at the data over time, this transcription rules, they present some variation. And typically you also have lots of rhotics that are expressed with single and double R, and other sounds that are expressed through the digraphs. So, and if you have very small data set, so your systems do not capture this correspondence between this kind of sounds or phonotactics and this character representations. So you might end up with some triple or even more times those R's, or duplicating some other sounds that are impossible in that language, and so forth. And finally, so this is the language that has the lowest accuracy. So it's abella. So this data set comes from the glossed text. And if you look at the number of forms and lemmas in that language, so let me just give you an example. So abella, where is it? So it has 918 rows and 470 lemmas. So it means that it's very sparse. So for a single lemma, you might have 1-2 forms, not more than that. But it's very complex in terms of morphology and the features. So here I presented some conversions that we worked and developed for that language. So you see that it has very specific features such as delayed imperative or different subject or hypothetical. So, and we try to find a good enough match in the existing schema, but still it's not always a precise mapping. It doesn't convey this particular meaning of the form itself. So it's very challenging in terms of the conversion. And it also requires prediction of the while lengths. And when you have such little data, your systems do not capture that almost entirely. Okay, so those are challenges in the conversion. Now, and how you can use the shared task and these accuracies to get some sense how good your annotation is. And finally, so this is almost the final part. So I will go very quickly through this. We observed that in some studies, people use Unimorph for typological analysis. For instance, to compare morphological complexities of languages. You should be very careful when you do that, because Unimorph is not equally representing languages. Because for some languages, if you look at this table, so this is from 2021 shared task. So for some languages, for instance, for some Slavic and Germanic and Roman languages, you have quite a lot of data. You see that for verbs, you would have several thousand samples representing, for instance, several hundreds of lemmas. And for Russian, you have quite a lot of data. And it's even not full data, it's only for the shared task. So it's a small sample of that initial data. For instance, for Polish, we actually have millions of entries and hundreds of thousands of lemmas. So it's a very small part of the Polish data. And they mostly contain full paradigms. So it's, of course, if you look at these statistics, you can say that it's safe to use these languages for your typological studies. But if you look at languages, for instance, Chukchi, Italman, or Kunwinku, you see that there are very few instances. So there are very few samples and very few lemmas. So it's 62 lemmas only to describe the language. Of course, if your language is polysyntactic and it's represented by a few samples, it means that it's very, very, very biased and it's very underrepresented. And if we look at the features, we see that out of 9 grammatical cases in Chukchi, we only have 3 represented in the data set. And out of 6 tenses, we only have 3. And there are no full paradigms, no single lemma that has a full paradigm for that language. And the same for abella, because the data comes from glosses. So you should always check how much data and how representative the data is. Again, you can guess that by the number of samples and the number of lemmas. So, and the final part is the current challenges and open questions. One of the major challenges is polysyntactic languages, because we still don't have an approach to describe paradigms, and it's not clear what the potential paradigm in polysyntactic language would contain. And of course, our representation of polysynthetic languages is very limited due to the problems that I mentioned before, because we cannot, we are still trying to develop the schema in order to be able to mark, for instance, different number of arguments and a varying number of cases and the dependencies. Another issue is the distinction between derivation and inflection is always fuzzy, so there's a continuum. In some languages, for instance, in Semitic, we might have masdars, which you can think of as deverbal nouns. And in languages such as, for instance, Russian, we don't have any derivational morphology. And of course, not all derivational morphology is unpredictable. So you can probably think of some English transformations that are entirely predictable. For instance, adverbial "ly" suffix, right? Or in some ways, absence of something like less or ability able. But even if we add this to our database, it's not clear how to describe these dimensions, those meanings of the derivations. So in the way that it provides the most accurate description of the transformation between the initial base form and the derived form. So there is no ambiguity, because in derivation, you still have some percentage of composition and non-compositionality. And another ongoing discussion is about this morphology syntax interface. In some languages, we have already clitics that come from the initial dictionary tables, but not all in all of them. And if you decide to include clitics or copulas, so your paradigms might grow exponentially without much extra information, because typically clitics do not add much information in terms of morphophonology. So you would probably imagine some solution like rule-based. For instance, you specify the inflection table, and then you say if you can add the following clitic to produce this another forms. So it's typically clitics are very, very regular, and they do not add much information in terms of some morphophonology. And so we are still discussing how to efficiently store these clitics and copulas and multi-word expressions. So, and I think that's it for my talk. I'm a little bit out of time, I guess. So please follow us on Twitter. So we would be happy to have you, and please join our team. So I'll stop sharing, and I'm happy to take questions.
Great, thank you very much.
Yeah, John,
yeah,
you have a question?
Yeah, John has a question, yeah.
Yeah, so thank you for this very interesting talk. So there's one thing that's kind of was bouncing back in my mind about my thing and about your talk, and maybe, I don't know how to put it too controversially, but, you know, the idea of, you know, you start by talking about how, you know, different languages have very different kind of structures, and you don't want to apply, you know, say concepts that have been applied in European languages to non-European languages. But then Unimorph sort of tries to build a single set of, you know, inflectional categories, right?
Yes.
So I wonder, to some extent, isn't there some kind of contradiction there? I mean, by building Unimorph, isn't that sort of, you know, applying categories that, you know, are still very European focused, you know, particularly things like gender, which, you know, one thing I always think is a bit odd is like gender and noun classes in Bantu. Saying those things are equivalent, I think, is a bit suspect. I think they're quite different in how they work in the languages and where they come from. So, you know, saying like gender is Bantu noun classes, you know, do you not run the risk of still sort of applying a very European perspective to languages?
Well, I would say that initially, when John Seeley Glassman look at the typological literature, of course, you still have some initial bias towards in the European languages. But as we are adding new languages, so we typically have working groups that in which we discuss whether we should extend this feature or we should call this feature in a different way to include some extra values into that feature. And in terms of this gender noun classes, so far we still assume that in majority of languages you would have it as gender. So if you have Bantu languages, those can be considered as exceptional cases, because those classes in Bantu languages cannot be generalized to any other languages. Or for instance, now Dagestan. So we consider them as LG-spec, but of course you can think probably to how to express these meanings, like to identify some semantic primitives, like in Wierzbicka's sense. So you decompose this human and non-human, or animate, inanimate, but then you have those liquid masses, right? So, and the question is how you express this meaning as liquid mass or abstract noun. And so far we have not addressed this. So we just assume that this gender classes cover majority of languages. They are more cross-linguistically attested.
Okay. So I guess my kind of follow-on was really then, I mean, what are the applications of having this signal morphology? Why not just have a separate tag set for every language? And, you know, are there applications where having a single morphology really, you know, is directly useful? Or
so far we use it to, of course, document this paradigms and make them comparative. So you can basically look at this instrumental case and how it's expressed across different languages, for instance, or study the complexity of this paradigm. So this was done already by some researchers. But in many cases, people use also to train their NLP systems or the modules on different types of morphologies.
Yeah, I'm interested to hear some. I don't know if you know, but I'd be interested to hear some of those use cases. Maybe it's something for me to look into myself as well.
Yeah, but kind of we are trying to make it more useful for typological studies and to as a way to document languages, but not the, like Wiktionary where you have all these specific features, but we are trying to map them into those comparative concepts so people can run studies on top of that. But we are trying to document how we map these features so that it's clear that it's this meaning is not lost. So it's not just some abstract LG-spec and everyone forgot what it is.
Yeah, and I guess it's very useful. I mean, a lot of languages are very related, and some concepts like having an accusative case, you know, that can come from different language families independently. And gender, of course, has also been invented in different language families independently. So it's not just a feature of Indo-European, you also have it in Semitic languages and many other families.
But of course, it's always like a discussion whether you can say that even Russian and Polish instrumental case is the same. And if you read like Wierzbicka or someone, they would claim that, okay, there are some subtle differences and you should account for these differences in the usage of the instrumental case. But if you would like to do some comparative analysis of languages, of course, you need to look at these common parts. Probably.
Yeah, and, you know, I mean, people have tried to reconstruct cases in Proto-Indo-European and, you know, they have some ideas of what cases might have been in Proto-Indo-European based on what's in modern Indo-European languages. Anyway, like, it's very interesting. I'll let other people ask questions.
Yeah, so are there any other questions? I haven't seen anything in the chat yet, I think.
Hi,
Priya.
Ekaterina.
Hello.
Thank you so much for the talk. I just have one question and about just a comment. So about the allomorphy errors. So is there any attempt from your side or from your team to, just lessen the allomorphy error, or how it could be, no more? How do we reduce that error?
We have not worked on this, but we are developing this tests on what type of allomorphy is not captured and what type of paradigms or what types of patterns are extracted by the system, so we can do this analysis.
Okay. The other thing is that I just when you talk about the genderlect, right? So I suppose what I know is that genderlect is very specific to some of the languages, but not a universal feature. So wouldn't it be more comfortable to put that as a language specific feature rather than incorporating them as unique for every languages?
So you mean to put a gender as something very language specific?
Genderlect, yeah, not about the gender noun classes, but genderlect, yeah.
Genderless? Or
no, the term that you mentioned about genderlect, that in some of the languages, I think it was a bill or some other, in where the male pronunciations and the female pronunciation is
okay, yeah, okay.
Right.
Yes, so you mean this genderlects, right?
Yes,
so gender. Yeah. So yes, you can put it as a feature, but of course, it highly depends how your text is annotated. So if you have this oral speech samples where you don't have this particular distinction annotated at all, so you cannot do much about this. So you need to have this prior knowledge that there should be such a difference in forms. And then, of course, you can introduce some either put it as two different dialects and to kind of have one file that is specific for male speech and another file that is specific for female features or speech. And or you can, yes, so you can just put it as LG spec.
Okay, thanks.
But my point is that it's something that we initially did not expect to have, right? It's not very common in across languages to have such distinctions.
Yeah.
I might have a question or two if no one else wants to go first. I think you showed you had like orthographical representations and also phonological representations. Does that mean that some Wiktionary tables or some sources have you have phonological forms from the paradigms, or did you transcribe yourself?
Yeah, you can produce. So we in the Unimorph we only have the orthographical representations, but there are projects. For instance, by Kyle Gorman, there's a shared task on grapheme to phoneme transformation. And they use their own database. So they also collected the data from Wiktionary, the graphemic and phonemic representation of words.
Okay, right. Okay, and another question is, what do you have some kind of quality check on the Wiktionary data? So is there a system in place where you say, okay, we check whether this data is good enough or
yeah, we have some set of scripts that check the consistency in the annotation and the tags, but typically for this data we use native speakers and linguists, so who check whether the samples are good enough. But for instance, in many languages, such as especially these historical languages like old German, middle low and high German, so we have many errors because no one checked that data so far, and we just found the linguists who worked on that languages, and we are trying to fix that. So typically we have the GitHub and people just come and say, okay, I know this language and here are some errors in that language.
Okay, interesting. One quick thing is I noticed recently a resource called Morphinet by Batsuren.
Yes, so we are working with him. So
okay.
he's now also joined the Unimorph, and we are trying to enrich the Unimorph with parts of derivational paradigms and segmentations.
Yeah, okay. Yeah, I have a few question or comments on that framework, but maybe I'll take that offline. But yeah, it's good to hear that he is involved there.
So we are trying to collaborate with him as well, because he also has scripts on extraction of the data from Wiktionary. Although we ourselves also we started using more linguistic resources than Wiktionary, because we're trying to enrich the Unimorph with more like under-resourced languages, and majority of that languages are not on Wiktionary. Well, they can be, but there are no paradigms or grammars of that languages. So there might be some few words with their translations into English.
Yeah. Okay. Thank you. I think we have another question from Rebecca. She wants to come in.
Thank you very much for the presentation. It was highly interesting. Now, my question is, for some languages such as Arabic, where the native language is more so the dialect rather than this modern standard Arabic, will you be taking into consideration the dialect sort of, or would it be just focused on modern standard?
So yes, a good question. So we have a group of linguists and annotators who are working on Arabic. So for Arabic, we have the standard Arabic and different dialects such as Gulf Arabic. So let me just show you this on the Unimorph website. So I'll share my screen. So we have Nizar Habash and Salam Khalifa who work on Arabic languages. So share. So we for Arabic, so we have this standard, modern standard Arabic. So let me. So it's Egyptian Arabic, Gulf Arabic, and yeah. So this is the modern standard, I guess. Let me just. Here. So we have Gulf Arabic and Modern Standard Arabic, which is Ara, and Egyptian Arabic, and that's it. So we have these three types of Arabic in our data set.
So will you be developing for more dialects? For example, not all of them use all the cases. For example, would it be taken into consideration in the future?
Yeah, of course, we are trying to include all the different dialects as well. For instance, in Uralic languages and specifically languages of Karelia, we have different dialects and supra-dialects, all these different categories of this, like languages of even like specific to certain villages, because there we have a group who are extensively working in Karelia to document these languages. So we have many different dialects of that languages. So it highly depends whether we have a group of people who worked on these languages and are ready to contribute.
Awesome. Thank you very much.
Yeah, thank you.
Are there any other questions, comments? If not, then I suppose we will close this session. Ekaterina, thank you very much for your.
Thank you so much for having me.
Yeah,
I really enjoyed.
Okay. Yeah. I hope we can collaborate in the future on some. Yeah, sure.
Just email me. So I left my email. So if you'd like to do any collaboration, we would be happy to have you.
Great.
Thank you.
Yeah, so I think I forgot to say in the beginning that it was the 8th installment of the Cardamom Seminar Series. Our 9th one will be also in February. So we will have 2 talks in February, and we will have Professor Dalith Pries from University of Bangor in Wales talking about Welsh speech and language technologies. So we'll spread the news on social media, and we hope to see you at the end of February. So thank you very much, and have a good day.